Okay, so Bismillahirrahmanirrahim. Today we will be continuing our topic on steel structure, but we will continue with the steel connections. So, okay, members of the structural steel frame must be connected together to form a rigid connection. Okay, as we know that the steel structure components comes in individual forms. Okay, dia datang sebatang-sebatang so kita perlu like connect them to form a structure. So there are four basic types of connections that can be used for steel structure: the bolt, weld, pin, and rivet. So the connection between members of normal steel frames are made by means of welding and bolts with angle clips and plates. So it's not just the rivets or bolts. We also have some plates to make sure that the connections are strong. Okay, so this is an example, okay, of a connection being made by welding. So the primary connection methods for structural steel are bolt and weld. So it depends on the purpose of these structures. So we need to determine which type of connections that we need to use depending on the purpose of the building. So for these connections, as I mentioned previously, some of them are made at the factory, which are known as shop connection, and then some of them are being made at the site. So these are known as site connections or field connections, right? So if you are going to use like bolts, the holes on the I-beam or steel structure are being made usually at the factory. And in terms of welding, some of them are made at the factory, whereas the rest of it, to finish off the connections, are being made at the site. Okay, so these are some more examples. Okay, you can see that the worker there are making some what you call field connections, okay, or site connections, right? Okay, so you can see there the connections are being made at the site. Okay, these are sorry, at the shop. So these are the bolt types of connections, and it's being lifted into position by using a crane. Okay, same goes here. So these are the types of connections that we mentioned: um, rivets, bolts, and weld. So this rivet, part of it is already have a head type of shape, and it will go through a hole. Okay, and then the other part is not formed yet in terms of the butt head here. So this part will be made at the side. Okay, whereas the bolts is easier. You just put in the bolt and then you put in the nut and then you tighten them in at a torque specified in the specifications. And these are the welding type of connections where The connections are being made at a much more what you call microscopic level lah. Okay, first of all, on rivets. So the rivet has been used for a very long time as a connection for steel structure. Right? So for example, here I mentioned the Eiffel Tower, 1889. Okay, so it uses 18,000 steel, piece of steel that needs to be connected. So it uses 2.5 million hot rivet. Okay, meaning that the rivets are being heated up before being slotted into the hole and being hammered, okay, to create the other butt head. So the use of rivet is very, what you call it, effective lah, right, to maintain the rigidity of the steel structure. So that's why it's being used uh, uh, for a very long time. So that's an example, right? But these days, we don't use rivets that much because we have other alternatives. Usually, it's need to be preheated before being driven into the hole to make it a bit easier to hammer the rivet into shape. Dia ada dua jenis ya rivet ni. Dia ada hot rivet and cold rivet. So and the other reason, labor cost, because needs a lot of effort to hammer the rivet into shape, and then there are costs involved. You have to bring up your machineries to help to hammer the rivet. Okay, and then there are noise involved when you hammer steel components, obviously, and there are also fire risk because we are heating up the rivet before we put them into place and we hammer them. So these are the rivets in its final shape. Okay, kita ada butt head ataupun button head, and then we have the shaft. So when we put the shaft into the hole in the of the structure, we will create another button head here by hammering the shaft. Okay. So having the shaft preheated helps in the process of um, shaping that button head or butt head. So as I mentioned, we don't use rivets and that much. Even though it performs very similar to bolt connections. Yeah. So rivets are being were replaced with high strength bolts. Okay, start 1960. So kita dah mula guna bolt and nut. Sebab menggunakan bolt and nut ni is a lot easier. You just put in the bolt and then screw in the nut, and then we use tools to tighten them up. So we do not need to like use we do not need to preheat the bolt and nut. Okay, so these are the rivet connections. Okay, you can see that um, can see that the button head at both sides of the connections. Okay, another example. So you can usually see this type of connections at old bridges, especially old train bridges. Laluan KTM yang masih menggunakan steel structure bridges, itu semua jambatan-jambatan lama yang masih kukuh sampai ke hari ini. Kebanyakannya menggunakan rivet connection. So advantage, they are cheap. Okay, using rivets are very cheap, even cheaper than bolt and nuts. Save the cost of electricity. Okay, no need for special material for connection. You just need the rivet and some hammer. That's it. Or if you want to make it faster, you can use pneumatic hammer. And the small size of the rivet allows transportation of larger quantities. Okay. And then increases production output. Requires preparation of both pieces to be connected. If you use welding, there's a lot of like surface preparation that needs to be done before you can start welding. So this is not the case for using rivets. So this decreases the production cost. And then flexibility in terms of design. So we can produce rivets in many shapes. The shaft can be in various lengths. And different steel can be used for creating the rivets. So overheaded tubular rivets. Macam-macam jenis rivet yang kita boleh order lah. And the rivets can be painted with the same color as the structure. And then durability, of course, these rivets are permanent. So once it's been hammered with the double butt head or button head, it's very difficult to take it off. You have to like grind them all the way to take out that rivet. So the material of the rivet itself is made out of very strong metals and alloys. And it also have anti-corrosive properties, especially if you use alloys. Easy inspection and maintenance. You can physically see the connections. So if there are cracks happening at the rivet, you can visually inspect them and doesn't need any specialized tool. If you are using like welding, you have to like check the connections on site whether the connection is solid or not. We have specialized tools to scan whether there are hairline cracks at the welding point. Okay, so that increases the cost lah. And then the disadvantage, even though the production of rivets application is simple, but it needs a lot of manpower. So it takes 4 people to complete the process of riveting. You also need to heat up the rivets before you hammer it into place if you are using a hot rivet. Okay. You can see the process there lah. One person to stand between the riveting position and the person who is heating up the rivet. We need one person to heat up the rivet, and then one person to pass it to the two person who will put the rivet into its place, the hole, and then uh, held it into position, and then the other one to hammer the shaft of that rivet to create a new button head. So a lot of work are involved in putting the rivet into place. And then this is an example. Oh yes, the weight of the rivet itself is heavier than other types of connections. So you have your steel structure at a certain dead weight, and then you have rivets. And you can see from a previous example, we use a lot of rivets even for just one connection, right? So this will increase the dead weight of the structure. And then the lack of aesthetic finish, of course. The steel structure that uses rivets does not look that pleasant, lah, right? You have all these butt heads at the connection of the steel structure. Doesn't look that appealing lah, compared to the clean look of welding. Welding tu nampak kemas dia punya connection tu. Does not look nice lah for the rivet connection. Right? So that is rivet connection. You can see this type of connection. Right? Nampak macam tak berapa kemas lah. Kan? Ni semua ni benda bulat-bulat ni, the button head banyak connection kat situ. Okay, kedua kita ada what's this bolting system. The bolting system. Okay, bolted joints are being used these days, okay, for securing the components of structural steel. So basically, they are fasteners that capture and join other parts and secured with the mating of screw threads. So welded joints are normally stronger than bolted joints, in great part because the material does not have the perforation needed for the bolted joints. So the bolted joints are not as rigid as a welded joint. Okay, so sometimes this can be an advantage for a building, especially buildings that are built in areas which are prone to earthquakes, right? So we need a certain degree of flexibility, not to save the building, but to ensure that the building does not instantly collapse. Okay. But if you are using welding, that building has a very high rigidity. So if it's not being properly designed in earthquake prone areas, when the welding fails, it can lead to uh, instant collapse lah. So we have two types of bolt connections. First one, bearing bolts in clearance holes, known as ordinary bolts or black bolts. So they are cheap, okay, in terms of acquiring them and to put them into position, right? So here you can see the connection between two I-beams as the column, and then kita ada plates that connect both of the I-beams, and then kita ada bolt and nut connections to secure those plates into position. So why bolting system are being used? So it's easy to install. Anybody can install a bolt and nut into a hole. Okay. So simple plate is inserted in holes drilled in two or more steel plate. Okay, let's see. This is the process lah. So usually the holes at the I-beam are being prepared at the factory. So when we want to connect all these parts together, these workers, they have a metal rod. Okay, they call it the pin. So the metal rod will be inserted into the holes of the metal plate and the I-beam lah. Okay, so that is a temporary punya fixing lah. So when the holes are aligned, dia akan masukkan bolt and nut tu one by one. Pin tu ada kat situ lah. So bila dah masuk banyak bolt and nut, dia akan cabut pin tu and then masukkan more bolts and nuts into position. So the plates are needed to strengthen the joint. Okay, sometimes the joints are even stronger than the I-beam itself. So if the loads are large enough, the bolts may fail by shearing. Shearing force ni maksudnya dia akan mematahkan lah. So we have like a bolt and then the shear force will akan snap the bolt into two. Kita panggil shearing ni sebagai ricihan lah. Right? Kalau dulu ada topik, ada apa, kursus static engineering, QS kena belajar. Sekarang dah tak ada dah. Okay. So those are shearing forces. Okay. Tenaga ricihan. So joints are required to resist shear between connected parts, designated as either friction type or bearing type connectors. During hoisting, mengangkat, right, connectors will install a minimum of 2 bolts per connection. So setiap sambungan tu paling minimum ada 2 bolts. Yang macam kat atas ni lah, right? Here you can see we have a minimum of 2 bolts. Berapa banyak nak digunakan ni akan ditentukan di kilang lah. Right? So the rest of the bolts are installed and tightened after the structure is plumb. So you have to make sure that the I-beam that you are installing as a column is really vertical. Okay, kalau tidak nanti bangunan you sengit. So when it is being plumb, then only we can start tightening up the bolts. Systematic pattern must be followed when tightening the bolts. Ada kaedah untuk mengikat bolt ni. You just di mana point yang ada banyak-banyak ni kan. Dia ada kaedah untuk mengikat dia. You cannot just simply tighten mana yang you suka. Dia ada pattern yang dia kena follow. Okay. Sama juga macam lug nut ataupun bolt yang ada pada roda kenderaan kan, kereta. Nak buka, nak ikat balik skru tu, nut tu, ada pattern yang kena follow. So this is a typical example of a bolt. Kena kenal lah bahagian-bahagian dia. Head, the shank. Shank ni tak ada thread. Yang ini thread lah. Dia ada bentuk kat situ. This is the length of the bolt. The grip. Then kita ada washer, kita ada the nut itself. So kalau bolt tu, when we say bolt is the head and the entire shaft ni lah. That's the bolt. Yang ini ialah nut lah. Sama ada kadang-kadang tu ada washer, kadang-kadang tak ada washer. Okay. So washers are hardened steel used in many structural connection to spread the pressure from bolt tightening process. So usually the washers are a bit wider than the nut. This is to ensure that the pressure that is being applied by the nut are being spread over a larger surface. Right? So washer can also be used to cover an oversized or slotted hole, although this is not recommended lah. Kena guna bolt yang betul untuk lubang yang betul lah. So kalau lubang tu macam terlalu besar, kena guna bolt yang berdiameter besar lah. Okay, so these are the washers. Kita ada flat washer. Ni yang paling biasa kita nampak. But there are also tapered washers yang ada angle sikit macam ni. So these are for slope surface. Ataupun dia punya lubang tu macam ada slanted sikit. So semua ni ditentukan semasa reka bentuk struktur lah. Okay, so this is the process of tightening up the bolts. Kat sini dia menggunakan electric punya driver lah kan. Dulu menggunakan pneumatic kuasa angin. Tapi punya mesin akan jadi bulky. So these days menggunakan tenaga elektrik saja senang. And the torque that is required to tightening up this bolt setelah dia set pada mesin ni. So dia tak perlu risau lah sama ada bolt tu terlalu longgar ataupun terlalu ketat. Okay, so these are some of the equipment. Ini yang saya mention tadi tu lah. Kita panggil pekerja tu iron worker. Spark wrenches, pin. Ni yang pin tadi tu. Yang dia macam masukkan ke dalam lubang untuk secure the metal plate and the I-beam. Sementara dia nak ikat bolt tu. Nak gunakan pada spark wrenches pun boleh juga. Tapi dia tak panjang lah. So spark wrenches, pin and correction bars. And then kita ada impact wrenches. Impact wrencher ni menggunakan kuasa angin lah. Kita tengok daripada hose ni pun kita tahulah. This is a pneumatic impact wrench. Yang ini kita rasanya macam kabel ni. And then dia ada motor kat sini. So most likely this is an electrical impact wrench. So impact wrenches will be needed for certain installation. Kalau yang mana angle yang agak pelik-pelik tu tak boleh masuk impact wrench tu, dia kena ikat secara manual lah. And then So this impact wrench either use electricity or compressed air. Kalau compressed air, kita perlu generator of course to generate electricity. Tapi satu lagi yang diperlukan ialah what you call air pump lah. So kalau menggunakan impact wrench yang menggunakan elektrik saja, kita tak perlukan this air pump. So kita kurangkan satu mesin. So advantage of bolting, less manpower. Okay, it doesn't macam bukan susah sangat kot nak ikat skru ni. So you can use like semi-skilled or unskilled worker. And then high strength bolt are much stronger than rivet. Okay. Hence the number of fasteners required for bolt are much lesser. So kita tengok pada bahagian bolt ni, dia punya connection dia tak begitu banyak, hanya di tempat ni saja. Kan? Kalau kita tengok rivet tadi, dia punya connection dia all over the place. Right? So kat sini dari segi estetik dia nampak much more clean lah. Right? Bolt connections are simple and faster fabrication, tightening. Of course, nak ikat bolt tu tak memerlukan masa yang lama. Kena pula you menggunakan impact wrench. Berbanding dengan menggunakan rivet dah lah point dia banyak. And then you kena create a new button head pula tu. Macam banyak kerja lah. And then of course dari segi noise tightening bolt enak much more silent. You tak mengganggu lah orang sekeliling. Nak hentam rivet tu, nak buat button head. Yang ni tak payah. And then bolt is also a cold process, no risk of fire. Tak perlu dipanaskan. And it can be removed, replaced or retightened. Kalau rivet tak boleh. Rivet kalau macam somehow or rather dia dah menjadi renggang, you have to cut that rivet away and then masukkan rivet baru, buat balik. Untuk bolt and nut ni tak perlu. Kalau dia renggang, longgar dan sebagainya, kita ketatkan balik. And then the connection support loads as soon as the bolts are tightened. Kalau rivet, kalau hot rivet, kena tunggu dia sejuk. Baru dia mencapai kekuatan dia yang sebenar. Bolt ni tak payah. Disadvantage, less aesthetic. Memanglah masih lagi lah nampak bolt and nut tu yang terkeluar dekat permukaan I-beam tu. And then unfinished bolt have lesser strength because of a non-uniform diameter. So bolt ni perlu diketatkan pada spesifikasi dia. So these are the ways that you can connect between I-beams for column. So kalau macam dia punya I-beam tu is the same, so dia punya connection pun tak adalah complicated sangat. But if your I-beams are like different thickness, dimension dia berbeza, so the connections can be quite more complex. Kalau yang ni macam, yang ni bahagian bawah ni I-beam dia besar, yang atas ni kecil. So kena tambah lagi satu seating plate dekat sini, kan, to make sure that the I-beam at the top tak slip downwards. So connection dia a bit more complex. These are beam-to-beam connections. Right? Dia menggunakan metal cleats ataupun menggunakan end plate. Alright, so let's see now. 43, kita take a break, okay, before we move on to welding. Okay. take a 10-minute break. Okay, thank you.